Okay, just another example of extratropical influence on the tropics before we move to the feedbacks between the tropics and extratropics. We discussed the MJOs crossing the maritime continent, and we talked about the impact of either the orography, the mountains on Sumatra, the land-sea contrast, the strength of the diurnal cycle, and maybe even the subsidence being driven from the Western Pacific, etc., affecting the transition across the maritime continents. And then there were issues about why they get detoured, and there were two ideas. Dae-Yoon Kim argues that the background humidity gradients in the meridional and zonal directions related to the Australian monsoon as well, for example, can create advections and moist static energy to the southern part of the maritime continent and creating a detour. And Zhao Lei argues that there is a air-sea interaction within the South China Sea, Java Sea region, so the western part of the Indonesian seas, where there is a feedback between circulation and and the MJO that detours it southward. The two explanations are not necessarily contradictory. It's just that Dae-Yoon Kim focused on the atmospheric processes and Zhao Lei focused on the air-sea interactions. This one is the same thing, but now looking at a slightly different angle. This one is talking about the propagation across the maritime continent, so they call them MJOC, where they cross the maritime continent, as you can see here, and those that are blocked. So they weaken and don't make it across here, whereas here on the Western Pacific side, the MJO is still active in the ones that cross the maritime continent. So the idea of this paper is, which is cited here below, is that there are cold surges from high latitudes or mid latitudes, which we talked about before in terms of being related to triggering convection in the tropics. So we said in MJO convection is impacted by these extratropical influences. This one is more specifically focusing on the ones that cross, which have these strong northerly wind anomalies or cold surges. Remember, MJO is a winter season phenomenon, fall, winter. Whereas the ones that don't cross and get stuck don't have that cross cold surge. So the convection that is triggered here is affected by the cold surges. And here the detailed process and potential link to the cold surge production and intrusion into the tropics is shown here. So the daily lag composite sea level pressure in hectopascals and 850 hectopascal winds, which is the top of the boundary layer, associated with cold surge events for the crossing MJOs, so MJOC. Day 0, so it is going from day 0 to day 3, -3, so sorry, D is day 0. This is going to -3, -2, -1, 0, 1, and 2. Okay, sorry about that. So you can see that the Siberian high blocking pattern here has this anticyclonic circulation. Sorry, there is a cyclonic circulation around it, which is got another sea level pressure center here, and there is a anticyclone, and in between these two pressure centers there is a surge. So it's starting with a weaker pressure center at minus day 3. Day -2, it's gotten more widespread and deepened, and this one has deepened as well, and you can begin to see the intrusion of these winds. And this is day -1 and day 0. So you can see that by day 0 the two pressure centers have almost connected with each other, and there is the anticyclone, and there is the strong cold surge into the maritime continent region, and by day 0 and day 1 they begin to retreat again. Okay, so this is another clear example of how the mid-latitude processes, you can see this wavy pattern here, and the waxing and waning of this Siberian high can we can call it West European blocking pattern, influences the cold surges and then the MJO propagation. So multiple explanations. It's quite possible that the MJO crossing of the maritime continent may depend on multiple factors, not just one particular process. So depending on the specific process involved, the details of how the moisture gradients and air-sea interactions and external forcing create this barrier to the crossing of the MJOs. But as I said before, whenever you averaged over the tropics, let's say 10 south, 10 north, or 5 south, 5 north, or even 15 south, 15 north, and you say MJO is blocked, one has to be careful because they may be steered southward and they may be detoured rather than blocked. Well, they're blocked in crossing across the maritime continent, but they are not blocked in crossing over into the West Pacific at a southern latitude, right? So if you look here, we said in the West Pacific the signature has disappeared, but if it is crossing into the South Pacific convergence zone, as a paper by Zaule shows, then it can have an impact on the South Pacific convergence zone amount of rain in that region as well, whereas the equatorial signature seems like it disappeared or it got blocked. So those details have to be looked at as well, but nonetheless that doesn't contradict the explanation given that the cold surges can trigger convection and facilitate crossing across the MJO crossing across the maritime continent. It's just that when there is no cold surge, one has to see if there are more detoured MJOs. That's the other part that's been not looked at in this paper.